Okay, so let's get back into the immutable storage solution. This is Dionysian Mist, and today we're gonna be working on the proof of work for it, which is using Blake 2B. So I have a whiteboard right here. So let's get started. So S proof of work. So this is the nano style proof of work, which uses 8 bytes and a certain threshold. So that'd be a U64 and a certain threshold. So threshold would be like O X F F F F F F A 0 0. Let's see, 2 4 6. 1 2 3 4. 1 2 3 4 5 6. So that would be the threshold, and for a nonce, which is a number that increments by 1 given a certain input, like a hash. So the nonce, we're gonna name this n. So n needs to be greater than the threshold. And sorry, it's not n, it's like hash function e. So that has to be higher than the certain threshold with n and the input hash. So to do that, I implemented my own library. It's called Blake 2B POW in crates to do the math, and let's get started on it. So that's on crates io. So once this is greater than that threshold, then it's considered a valid nonce. Which means that we can then accept the transaction. So that's the basics of that. Let's get into the code for this. So to do this, we're gonna have to go to core and let's add proof of work alt I'll call this mini proof of work. And I added Blake to be POW. Okay, so let's get started with this. So what we're gonna do is do a use statement. Actually, I have to add mod mini proof of work, and let's start with this. So mini proof of work and uses Blake to be to generate a nonce to generate a valid nonce given an input such as a transaction hash or in this case the, the piece data bytes. So let's get started with this. So we're gonna use Lake to be I have mine and verify nonce. So let's do mine. So first we need a constant for the threshold. And that's going to be a U64. If you go into my old documentation, we have this for one of them. So let's just set it as that. That will take some time, and we can measure the time, the average time it takes to mine in each case. But that's just one threshold. So that will be the threshold for let's see, piece threshold. So then we have to mine something. So let's take a random string. Actually, let's first do a nonce. So type nonce is going to be equal to a U64. Let's call this mini proof of work nonce. And let's make a function called proof of work. And let's just do use to be proof of work line. And what we're gonna do is take a random data. So this is what it says for it. And it's proof of work concept. So it's actually or equal to. So let's check on this. So what we first want is to import my libslug library, and I'm just gonna use the API. Slug CSPNRG. So what we're gonna do is generate some randomness. This is just for testing from OS, and we're gonna feed that into here. We're gonna name this bytes RNG bytes, and the threshold is gonna be piece threshold. Let nonce equal. And this one's gonna have to be referenced, and we're gonna print. And we're gonna actually return nonce. So let's see how this works. I'm going to go to the next one. Mining, and then return nonce. And then let's just add a test. And we're gonna print. And for this, I'm gonna make an easier one. We're gonna call this mini piece threshold, and we're gonna make this 0, 0, 0. That shouldn't take too long. So now let's put mini piece in here and see how this works. So again, this is using nanos, the block lattices way of proof of work. It's a really cool idea. I like the company a lot too. They're a really good company. If like you want to send transactions for free without waiting, Nano's a great company. So you can look into them. So let's see what this does. So that was quick. It mined actually pretty quickly. So let's try a harder one. So went up to 54,784 for valid nonce. Now let's try piece threshold. you you can see it's taking a while to do it. So it must be working. So this is proof of work. It takes a while. So to deter spam and a few other things. So for pieces that are larger, I can make sure that they have a higher threshold so it doesn't spam the network with a lot of data. And you'll have to include the nonce with it so that it can be uploaded. Okay, so it's been over 60 seconds already, and we still haven't had a hit, so that's using the peach threshold, which is this one, which is all those ones. This one's a different. Should work pretty soon. I think the time for this is about 2 to 5 minutes. And while that's working, we can start working on the actual usage of this. It's going to accept bytes, and it's going to accept threshold as a U64. You you can see it's still running, so I'm pretty sure this number will be larger than usual, but because it's so large, I it it could take it it could take a while, so not this, but but like my my bad, I'm not speaking right now, but let's drop that subject because that just my mind just blanked out. So back to mini proof of work. We're gonna have Blake to be proof of work line. Then we're gonna have bytes and threshold. So that's just a wrapper over this. There there we go. It's complete. It got 35658,294. So so that was a valid nonce for that one. It took about I'd say 3 to 4 minutes, maybe less. But that's how proof of work works. So well, this is a special kind called mini proof of work, and let's get into this. So what we're gonna do is take out all this. So now we can use it with this, and let's add a verify. Return the boolean statement. So that's our basic mini proof of work for this. It works like this as like you can see, and once it has that valid nonce, you can accept the transaction. So that's how the proof of work part of this. I'll name it mini proof of work nano for this. That's how that works. I'm thinking about switching to Blake 2S, but I'll have to do that later. Thanks for watching this video. Please like, subscribe, and comment to see more.